In this video, we're going to look at percent increase and decrease applications. Find the indicated amounts and round your final answer to 2 decimal places as needed. So let's look at the first problem. I'm going to highlight the givens and the goal. So Juliana changed careers. Her old salary was $53,000 a year. Her new salary is 26% more per year. So notice that's a percentage increase. They didn't say, $4,000 more a year. It's a percent more of her old salary. And we're asked what her new salary is. So we'll highlight that in green because it's a goal. Okay. So we're going to do this one in 2 ways. One way, which you're probably more familiar with. We're asked to find her new salary. One way we can do that is find what the increase was. We could find what 26% of the $53,000 is and then add it on to $53,000. So let's start that way. So what is the salary increase? And we take $53,000 and find 26% of that. So 26 out of every 100. Times 26 over 100, which gives us $13,780. So now that we know the increase, okay, and it's tempting, a lot of times people find this number and say that's your answer, but we want the new salary. The new salary is her original salary, $53,000. Plus, let's change colors because we're getting close here, the $13,780. And we could do this in our heads, but let's check it on the calculator. Add 53,000 to 13,780, and we get 66,780. Okay. And that's a completely reasonable way to do this problem. But let's think of this in terms of percents. Well, her new salary was the $53,000 a year, which is 100% of $53,000. And this value, $13,780, we got that by finding 26% of $53,000. So we could also say the new salary is 100% of the old salary plus 26% of the old salary. So 126% of her old salary. Okay, so both of these were relative to her old salary. I didn't write it out because that's a little bit long. So to find that, we can just take the old salary and find 126% of it. Well, that's 126 over 100. So 53,000 times 126 divided by 100. And notice we get the same result, 66,780. Okay, so 2 ways to do the same problem. And this way is a little bit more streamlined. Okay, you can just add the percentages first, which is easy because they're usually whole number percentages, and just do the one computation at the end. So let's try the next one this way. Jordan lost 17% of his body weight over the school year. If he originally weighed 247 pounds, so that's all given information, here comes the question, which is our goal. What is his new weight? Okay, so notice it didn't ask us how much weight did he lose, so we don't even need to find that value unless we want to. We want to find his new weight. So his new weight is going to be his old weight, which is 100%. We'll just put old over here, minus 17% of his old weight, which is 83% of his old weight. So since this is a percent decrease, notice here it was increase, we added the 26% to 100%. Here it's a decrease, so we subtract 17% from the 100%. Now we're going to find 83% of his old weight, which is 247, times 83 out of every 100 pounds he kept. So 247 times 83 over 100 gives us 205.01. Okay, it's said to round to 2 decimal places. Kind of want to give Jordan the 0.01 pound loss, but got to follow directions. Okay, so that's his new weight. Okay, notice if we wanted to, the difference is about 42 pounds. That's about how much he lost. Let's look at the next one. The CPI inflation calculator, so this stands for the Consumer Price Index, measures the buying power of a dollar relative to different years. According to the Bureau of Labor Statistics, $1 in 1985 has the same buying power as $2.23 in 2016. So you may have noticed, depending on your age, if you think back, 10 or 15 years ago, maybe candy used to cost 45 cents. Now maybe it's 95 cents. So in general, inflation is the idea that prices increase, but usually our salaries increase along the way relative to that amount, so we can still continue to afford things. Okay? So this is the relevant information, and we're asked 2 questions. What is the multiplicative factor and percent increase from $1 to $2.23. Now the multiplicative factor, remember that's asking us, since we're going from 1 to 223, we're saying what number do I multiply, that's an I not a 1, by $1 to get 223. And remember, to find multiplicative factors, we divide. So this is 223 divided by 1. These are both dollars, but the dollars cancel out. This is, remember what we called a scalar number. It doesn't have any units. So the new buying power is 2.23 times as large as the old buying power. Okay. Now for percent increase, it's not going to be the same value, because the percent increase, we're thinking if I have $1 and I'm going to say that 23, it's about a quarter, so it's about here. We want to see the difference relative to the whole. Okay, so these two match up. Okay, then there's one full copy more, or 100% more, and this percentage more. So it's going to be 123%. Now it's easy to figure it out with since one of these numbers is 1. Let's see how we do this symbolically. Okay, so first we're going to find the difference, and we're going to divide it by the original amount. So the difference is 223 minus 1 divided by the original amount of 1. Okay. So 223 minus 1 is 123 over 1. I'm sorry, 1.23 over 1, which gives us 1.23. Okay. Now we're going to take this value and write it as a percent. Okay. So 1.23 times 100% is a 123% increase. Okay. So it's 2.23 times as large as $1, but the increase from $1 to 223 is 123% relative to the original $1. Let's look at the next one. If Joe's salary in 1985 was $25,000 a year, here comes the question. how much would he need to make now just to keep up with inflation? And by now we should say 2016, in case you are not currently in 2016. Okay. So notice we could think of, well, how much would his salary need to go up by as a percentage? Or we could just directly use a multiplicative factor, which is like what we did when we found the other percent increases and decreases. So notice he'd have his original $25,000 plus 123% more. Well, that would be 223% of the original, which is like multiplying by 2.23. Okay, so his salary in 2016 would be $25,000 times 2.23. So that's going to be 50,000 and a little bit more. Let's see exactly. 25,000 times 2.23, which is 55,750. So you could think of this equivalently as someone having a salary in 1985 of $25,000 is about the same as somebody having a salary of $55,740 in 2016. Let's look at one more. If Joe's salary is $62,000 a year in 2016, how much more is he making in addition to the inflation adjustment? Okay. So you'll find when you get a full-time job, or if you already have one, that they usually give you a cost of living increase every year, but then hopefully you also get raises. The more time you spend there, the more valuable, and you get additional raises. So if he was making an equivalent amount with just covered the cost of inflation but didn't really give him a raise, then he'd make the $55,000, but he's making $62,000. So he's got a little bit of a raise in there. Okay, it might be tempting for Joe to think, I make more than twice the amount than I used to make, but only this small amount. It's not nothing, but it's not as much. Oops, excuse me. 62,000 minus 55,740. So 6,260 is pure raise.